What if the first distant giant world quietly broke every rule? A massive sphere burns close to its star like a misplaced ember. Tonight, we follow a faint stellar tremble that changed astronomy forever. Welcome, gentle mind, into a quieter layer of the night sky. Breathing slows as distant starlight hums beyond thought. Instruments rest like patient listeners, waiting to hear motions smaller than a whisper. Above, Pegasus stands suspended in silver stillness tonight. One sun-like star glows with a nearly hidden rhythm. Spectral lines sway gently, like curtains shifting from an unseen breath nearby. No blaze erupts. No dramatic flash demands attention here. Only motion, delicate and repeating, shapes the mystery. Gravity leaves handwriting inside light, and careful minds learn slowly how to read. Astronomers named the distant world 51 Pegasi b first. Another name, Dimidium, drifts with softer sound. Two identities circle one heated giant wrapped tightly in fierce stellar glare. History shifted when a planet appeared around a sun-like star. Before that moment, such worlds lived mostly inside theory. A G-type beacon finally revealed a companion through measured motion. October 6, 1995, passed quietly across Earth. Inside observatories, screens glowed with cautious excitement. A small radial velocity signal carried meaning far larger than expected. 50 light-years stretch between Earth and that distant star. Distance feels immense, yet gravity bridges the gap easily. Spectra carry evidence across darkness without losing clarity or rhythm. Michel Mayor and Didier Queloz listened where others heard noise. Geneva nights and Haute Provence air held steady patience. Spectrographs trace stellar shifts like seismographs tracing distant hidden quakes. The radial velocity method follows tiny color changes in light. Blue when approaching, red when drifting slowly away. A hidden planet conducts the rhythm through steady gravitational pull. Dimidium belongs among hot Jupiters, giants living close to fire. Massive, gaseous, swollen beneath relentless stellar heat. Atmosphere stretches outward like a storm cloud trapped beside a furnace. One orbit lasts only 4.23 Earth days there. Years rush past faster than quiet human weekends. Orbital motion feels like a racing pulse beneath constant waves of radiation. At 0.05 AU, separation becomes almost intimate now. 20 times nearer than Earth's familiar path around the Sun. Space between star and planet glows with restless energy. Mass reaches nearly half of Jupiter's familiar bulk. Smaller than our giant, yet still overwhelmingly vast. Gravity there would sculpt clouds into towers beneath crushing atmospheric weight. Tidal locking likely keeps one side facing daylight always. Opposite regions linger under endless, unbroken shadow. A ring of twilight circles between extremes like a quiet border. Temperatures rise between 1000 and 1250 Celsius there. Radiation pours across skies without pause or mercy. Silicates and metals may drift as vapor, forming shimmering mineral clouds. Older formation theories placed giant planets far from stars. Cold outer regions seemed safer for massive growth. Dimidium circled close instead, challenging comfortable expectations held by planetary scientists for decades. A gentler explanation emerged through planetary migration models. Worlds may form distant, then travel inward gradually. Gas within the young disk acts like tides, guiding slow orbital rearrangement over time. Angular momentum exchange becomes the quiet sculptor of systems. Massive bodies shift while disks redistribute motion. Planetary neighborhoods change long after formation ends, like cities rearranging under unseen gravitational planning. One measured wobble expanded astronomy's horizon almost overnight. After Dimidium, planets elsewhere felt inevitable, not speculative. Telescopes worldwide joined the patient search for further stellar motions. Questions evolved from existence toward astonishing diversity. How many worlds circle distant suns tonight? How strange might climates, atmospheres, and surfaces become across the galaxy? Each radial velocity curve carries a familiar signature now. A repeating shift, steady and persuasive. Hidden companions announce presence through rhythm rather than light. Decades later, recognition arrived like delayed starlight reaching shore. In 2019, a Nobel Prize honored the discovery. Careful spectral listening reshaped humanity's understanding of planetary abundance. No image revealed the planet directly to human eyes. Gravity alone exposed companionship around that star. Science sometimes advances through listening more than looking. The host star resembles our Sun in classification and behavior. A G-type main sequence furnace, slightly brighter overall. Familiar qualities make the nearby giant even more surprising. Atmosphere remains unseen, yet models suggest extreme conditions above. Vaporized metals and silicates may drift in heated layers. Clouds there could shimmer like molten mist. Those clouds contain minerals instead of gentle water droplets. Chemistry unfolds where temperatures melt stone easily. Winds move elements through glowing, restless circulation patterns. Radiative transfer governs energy flow across atmospheric depths. Incoming starlight scatters, absorbs, then re-emerges as heat. The giant world glows like stirred embers in darkness. From Earth, no transit shadow crosses the star's bright face. Radius remains uncertain without silhouette measurements available. Knowledge sometimes arrives incomplete, yet still deeply meaningful. Radial velocity still provides minimum mass with strong reliability. Orbital period and distance emerge clearly from curves. Gravity leaves fingerprints precise enough for confident interpretation. Detection stands as a milestone within astrophysical history. First confirmed planet around a sun-like star. A beginning point from which countless discoveries later unfolded. Many known exoplanets trace heritage back to that signal. Dimidium stands like an ancestral whisper in data. A vast planetary family followed after the first confirmed detection. Instruments improved, refining spectroscopic sensitivity year after year. Precision sharpened like hearing adjusting within darkness. Fainter stellar wobbles gradually became measurable signals. A boundary separated speculation from measurement after discovery arrived. The universe felt structured, populated, quietly dynamic. Orbital stories multiplied beyond earlier imagination. Yet a question lingered like warmth after sunset fades. How could a giant remain so close? Radiation argues strongly against gentle nearby formation. Earlier models placed gas giants beyond icy regions outward. Those colder zones served as nurseries for growth. Dimidium circles well inside that traditional boundary. A hot Jupiter stood where emptiness once seemed certain. Doppler shifts carried the puzzle patiently to Earth. Orbital speed deepened the mystery further. Planetary migration through disk interactions offers a calm explanation. Formation likely began beyond the frost line originally. Gas tides slowly guided the world inward. Like a boat carried by steady, unseen currents, orbit changed. Disk torques reshaped the path over long spans. Movement continued quietly long after planetary birth. Planets do not always remain near original birthplaces. Large worlds can travel across stellar systems. Dimidium proves orbital evolution shapes planetary architecture. The first detected distant giant broke rules through migration. Born in cold regions, later moved towards stellar heat. Presence records ancient motion within a young disk. Resonances, torques, and friction shaped the final orbit slowly. Physics acted patiently rather than suddenly. Once forbidden positions became natural outcomes. Dimidium serves as messenger rather than strange exception. Planetary systems shift and rearrange across time. Worlds drift like pieces across a grand celestial board. Now every stellar wobble carries deeper meaning for observers. Another traveler may hide within shifting light. Each signal invites careful listening. Pegasus no longer feels empty in the quiet sky. Memory of discovery lingers among those stars. A turning point rests overhead. Night grows calmer as understanding settles gently within. Data softens into story and perspective. The universe feels warmer, fuller, alive. If this gentle exploration of planetary motion brought calm curiosity tonight, many more distant mysteries wait within quiet starlight. Subscribe, like, comment, and share so our journey through the universe continues together.